In this lecture, we will discuss about CHATELIER'S principle. As you know that in a reaction, state of equilibrium is said to be attained when the rate of forward reaction becomes equal to rate of backward reaction. At this stage, amount of each constituent of the reaction mixtures become fixed, but the reaction never ceases. Equilibrium is denoted in a chemical equation reversible sign or reversible symbol. The rate of chemical reaction means the change in concentration per unit time. Since change in concentration with time is never uniform, therefore, the reaction is considered for a small interval during which change in concentration is small. Hence, the rate of reaction is equal to minus dx by dt. There are many factors that affect the rate of reactions like concentration, temperature, pressure, nature of the reactants and catalyst. CHATELIER'S principle is an observation about chemical equilibrium of the reaction. It states that changes in the temperature, pressure, volume or concentration of a system will result in predictable and opposing changes in the system. And in order to achieve a new equilibrium state. In another word, it can be stated as when a system at equilibrium is subjected to a change, the equilibrium shifts in a direction as to nullify the effect of the change. It is applicable to any system at equilibrium. It can also be applied in a chemical reaction and the change can be brought about by changing temperature, pressure and concentration. If concentration of any one of the reactant is increased, then the equilibrium shifts in forward direction and vice versa. In the reaction, hydrogen reacts with hydrogen iodide to form iodine to form hydrogen iodide, and this is reversible reaction. And when hydrogen is added, then more hydrogen iodide will be formed, and if hydrogen iodide is added, then hydrogen iodide will be decomposed to form hydrogen and iodine. So, the concentration of any one of the reactant is increased, then the equilibrium shift in forward direction. And if the concentration of reactant is increased, the equilibrium will shift in forward direction, and if the concentration of product is increased, the equilibrium will shift in the backward direction. Second is pressure. A change in pressure or volume will result in an attempt to restore equilibrium by creating more or less moles of gas. If the pressure in a system increases or the volume decreases, the equilibrium will shift to favor the side of the reactions that involves fewer moles of or lesser moles of gas. And if the volume of system increases or the pressure decreases, the production of additional moles of gas will be favored. And in a simple way, we can say that if in a reaction there is decrease in volume, the increase in pressure will shift the equilibrium in forward direction and vice versa. In the above reaction, in this reaction, formation of ammonia results in decrease in volume, because 1 volume of nitrogen and 3 volume of hydrogen, reacts to form true volume of ammonia. Hence, at high pressure, more ammonia will be formed. If there is no change in volume in the reaction, then change in pressure have no effect on equilibrium. Another factor is temperature. It depends on the types of reaction. As we know that there are two types of reaction, endothermic reaction and exothermic reaction. In exothermic reaction, heat energy is liberated, but in the case of endothermic reaction, heat energy is absorbed. And if the temperature of the system increases, the equilibrium will shift in the direction of the endothermic reaction. And if the temperature of the system decreases, the equilibrium in the direction of the exothermic reaction. Let us consider a reaction, nitrogen plus hydrogen, it forms ammonia, and this is example of reversible reaction. Here formation of ammonia takes place with liberation of heat or evolution of heat, and this is the example of exothermic reaction, and decomposition of ammonia takes place by absorption of heat and is an endothermic reaction. If temperature of the reaction is increased, the system will absorb the heat and therefore more ammonia will be decomposed. Hence, in order to prepare more ammonia, temperature of the system will have to be reduced. Therefore, if a reaction is exothermic, there will be low temperature will shift the equilibrium in forward direction and vice versa. Addition of inert gas. An inert gas will not react with either the reactant or the product. So, it will have no effect on the product reactant ratio, and therefore, it will have no effect on equilibrium. And system will always shift so that the ratio of product and reactant remains equal to Kp or Kc. Another factor is effect of catalyst. Catalyst is a substance that can influence the rate of chemical reaction, but is not consumed itself and remains unchanged after the reaction. There are different types of, or there are many types of catalyst: positive catalyst, negative catalyst, auto catalyst, induced catalyst. The presence of catalyst does not disturb the state of equilibrium. It only hastens the attainment of equilibrium by providing a new pathway having low activation energy. If a reaction is exothermic, then low temperature will give more product, but the rate of reaction will be slow. Hence, use of positive catalyst. Positive catalyst accelerates the rate of chemical reaction. Hence, the use of positive catalyst in a reaction is must to increase the rate of formation of the product. Similarly, in endothermic reaction, high temperature is necessary condition for the formation of product, but at high temperature rate of reaction becomes fast. Hence, in such a reaction, there is no need of using a catalyst. In next video, we will discuss ionic equilibrium or degree of dissociation. Thank you.